In the previous classes, we've been discussing about database technologies and how we can interact with database using ASP.NET. Today, we're going to continue with that. We're going to go to the third and the most important way in which right now ASP.NET is talking to databases called entity framework. Okay, so I'm going to focus on this keyword called entity framework, and it is a framework which is built on top of our .NET framework in order to give us an ORM. Okay, I'm repeating that word, ORM, object relational mapping. Okay, so I'm not going to take much time in this, guys, because we have already seen language integrated query, how it looks like. Okay, so this is basically link to entities. Okay, instead of directly talking to, but then there are some advantages and disadvantages. I'll discuss it in the program when we start, but this slide is only put only to explain the framework and the theory part of it. I'll quickly wind this slides up and then we'll go to the program itself. So let me just begin. We are going to see what is an ORM, what are the basic concepts of ORM technology, and then what is entity framework, how do you use link components inside entity framework, and how do you use it in Visual Studio. That's what I want you to learn. Okay, moving on, we'll see what is ORM. Okay, so ORM is a programming technique for automatically mapping and converting, please note those two keywords, between relational database tables and object oriented classes and objects. Okay, please remember that is the mapping. It's a mapping or automatic conversion between relational database tables and object oriented classes and objects. Okay, this is the mapping which we are going to do, which we have already done in link. Okay, using link technology, but then the more sophisticated and currently used way is entity framework. Okay, link is also there, but it is still it's not so much used when entity framework is already there. It is a better version. Okay, right now what code we write might not have a difference in the execution because it all works fast, but when there is a huge amount of data, framework works much better. And plus, one more advantage of entity framework is that it can work with any database technology. All right, but link is almost restricted. 90% is restricted to Microsoft SQL Server. But when it comes to entity framework, because you can't restrict a person who's doing ASP.NET project to only use Microsoft SQL Server. He can also use MySQL or PostgreSQL or Oracle, whatever he feels like. So that is allowed in entity framework. Link will be a little bit more, what do you call, it's a challenge to do that in language integrated query. So basically why we are talking about this right now is because entity framework is an object relational mapping framework, which basically connects or maps between a relational database, which tables, and object oriented programming, classes and objects. Okay, it creates a virtual object database, okay, which can be used within our programming language. That's the reason why we discussed language integrated query first. All right, and then normally these frameworks automate the ORM process. Okay, the process of converting or mapping this, these frameworks of ORM normally automate this process. In Java, we have a framework called Hibernate. Okay, Hibernate is an ORM technology. What does it do? It converts all database tables or maps the database tables to your object-oriented Java programming classes and objects. Okay, let me move on. They normally provide these four functionalities. Okay, starting with number one, creating an object model by using the database's schema. Okay, I hope you know what's a schema, like the description of a table, DESC. What you see there in DESC of a table is what we are going to create an object model using that description. Second one, reverse, creating a database schema by using an object model. Okay, what is an object model? How do you create a class? For example, I create a class called employee and then I put some properties in them like employee ID, employee name, like that. I keep, for example, if my class name is class employee, inside that I have int employee ID, string employee name, like that. If I keep, this is the property, this is an object model. Okay, so how will an object look like? For example, E1, if you say create an object of employee, you get E1, and then you say E1 dot employee ID is equal to so and so, E1 dot name is equal to so and so, like that you can keep. That's an object model. Okay, the same thing, how will I write it in database or database schema? I create a table called TBL employees, and then I create a column called employee underscore ID, which is int. Okay, and then integer. In other words, another one is employee name, which is varchar. Okay, so these two can be mapped. That's the idea. Okay, and querying data. To query data by using the object oriented API. All right, it is not database oriented because I need not learn SQL at all here. I just need to know how database is structured. If I know the structure of it and I can convert it into an object model here in my programming language, all I need to do is query data using that object oriented API. Okay, finally, obviously, manipulation operation like CRUD, okay, create, retrieve, update, and delete. All those things are possible, and they normally automate this process. Okay, so ORM frameworks automatically generate SQL to perform the requested data operations. We had seen this already, that's why I'm not taking much time in these slides. Okay, we have already seen that in the last program, what we did, language integrated query, I wrote everything in C#. Okay, but do you think SQL was not generated at all there? No, it was generated, but not by me. Okay, system generated the SQL and executed against the database and gave me a response. Okay, please remember that. Moving on, what is an example? Okay, so you see that there's a diagram here. I know it's not so clear, but then just look at that. One side what you see is a database structure. The other side what you see is a class diagram. Okay, one is a relational database schema. The other one is a class diagram. Okay, in this case specifically, it's an ORM entity. In other words, C# classes. Okay, so each class here, for example, employees, there are so many records there. This is how you store it in a database. Here I have employee as a class, and these are the properties of that particular employee class. Okay, this in between stands your ORM framework. Okay, what are the advantages? Number one, productivity, because you will write less code. Okay, just take your ADO.NET connected or disconnected architecture and check the update code or insert code with what we have done in language integrated query, and you'll see the difference. Absolutely, it is different because one, you had to write single quote, double quote, single quote, double quote, and put parameters and write SQL query. You need to know SQL query, you need to know where to start the single quote, where to stop the double quote, etc., etc. We need to look at a lot of things, and the code was getting bigger. Now, all my examples, I have only taken 4 records, but in real world, it is not just going to be 4 records. It can be n number of records. When there is n number of records, writing code in SQL through your program, any programming language for that sake, will become tedious. Okay, will become hectic for us once it goes to a live project and a lot of tables are there. But when it comes to this object relational mapping, like link or entity framework, all those things are reduced. Your code will look very small, very simple, and it is easily understandable if you know object oriented programming. Okay. And second thing is that it hides your complexity. In other words, it abstracts from differences between object and relational word. You do not know how the code is getting executed, how that SQL code is getting generated. We need not bother about it. The system will take care of it. The complexity is hidden inside the framework. You need not bother about it. Okay. And manageability of CRUD operations for complex relationships. Right now, what we have done is one table. But imagine if I had multiple tables and all are connected with each other, it again becomes a tedious task of writing SQL query with joins and stuff. But when it comes to link or entity framework, you don't have this issue. Okay, the manageability of that complex relationships and performing CRUD operations on them becomes easier. And obviously, maintainability. Okay, you can easily debug an issue which is there in these entity framework and link based programs rather than ADO.NET based programs. Okay. What are the different approaches to ORM? There are template based ones and then the entity class mappings. Okay, I'm going to use the template based code generation. It's going to generate the code and the mapping for us. Okay, and I'm going to write language integrated query, in other words, link to entities, but then SQL is going to get generated, design time or runtime. Okay, and already existing SQL can be mapped also. That is also another approach for us, but we don't use that. Okay, next one is entity class representation. How do you represent an entity here in C#? Plain old C# objects. What we had done in ADO.NET third program when I did, I used this POCO. Okay, plain old C# objects. Okay, that is also possible, but we need not create that POCO here. System will automatically do it. Okay, and these are all mapping, so I will not bother about it. Let me go to the next part. Okay, so you see code generation, you normally have C# will be generated, XML will be generated, source code will be compiled, it can be customized, etc., etc. Okay, and object relational mapping tools are normally built with XML in the middle. Okay, so please remember that. And let me go to the diagram here in .NET. What we have seen so far is just ORM in general, but in specifically in .NET, you have ADO.NET Entity Framework linked to SQL. Both of these combine and give you SQL at runtime. Okay, please note SQL is generated at runtime. which means by the time you reach or you compile the code, your code, if it is successful in Visual Studio, 90% of the time it will also get successful in the SQL part, because SQL is generated at the runtime. All right. The previous method or previous approach, what we were following is SQL was written in compile time. So, which means we write it there. Okay, we write it and we compile it, nothing will happen, and the SQL will get executed against that database at runtime. But here, SQL only is generated at runtime. All right, and it is not generated by humans, which means we don't do it, system does it. So majority of the time, okay, let's say 90% of the time, you will not get any errors because system has already processed and thought about how that SQL will be. Okay, and there might be not any issues with that particular case. Okay, and third party, there are third party tools. Okay, not just linked to entities. There are third party, but they are not as famous as entity framework itself, because it is supported by Microsoft directly. The N-Hibernate and Telerik, these two companies have a separate what do you call framework, which is allowing you to use ORM before entity framework came into picture. But then once entity framework is there, these two are not much sought after right now, because Microsoft gives wonderful support for entity framework. So people normally choose entity framework above any other framework which is available. Okay, so let's look into Area.NET's entity framework architecture. Okay, it is a standard ORM framework. It is part of .NET. Okay, and these things I think I've already explained about it, and it is also mapped to an object model. All right, so Visual Studio has a lot of inbuilt tools for generating entity framework. I'll show that right now. Okay, how an entities can be created and generated here in in Visual Studio. Okay, and I'll not focus on this much, guys. Let's just see the diagram and then we'll move on. Okay, basically this can be also called as link to entities. Okay, they are built on top of ADO.NET and link. That's why we learn this towards the end. We learn ADO.NET first, then we learn language integrated query, and then we learn entity framework. Okay, and the reason we are learning it is because entity framework is built on top of these two things. Okay, so now if you ask me what should I use when I'm creating a project in ASP.NET, which technology should I use? Should I use ADO.NET? Should I use link or entity framework? Answer is obviously entity framework. Okay, we do not expect you to work with ADO.NET or link if you are starting with a new project. But please do understand the reason why we had discussed ADO.NET and link is because there are some companies in which they still use ADO.NET because the original code was written like that. Okay, so we need to give support to already existing code. We can't modify all code which is right now there into entity framework. Entity framework is a recent framework. Okay, ADO.NET is the age-old one. From the beginning, it is there. So all projects in ASP.NET or .NET in general, which were created earlier, right, will still follow ADO.NET, which means you need to understand how ADO.NET works, just because if at all you are working in a company which uses .NET technologies and they are still working with ADO.NET, you cannot say that we'll change everything to entity framework. We'll have to work with ADO.NET some point of the other time. So that's why we learn this. And link we learn in order to understand the syntax of how to use it in entity framework. Okay, so link to entities is Microsoft's entry level and link enabled ORM implementation for database servers. It works with SQL Server, because please note, they will obviously highlight their product only first. Microsoft's product, which is SQL Server and SQL Server Express, but it could also work with MySQL, SQLite, Oracle, etc. That's the advantage of using entity framework. Link cannot do that. Okay, link takes a little bit more complicated way in order to achieve different data sources. Okay, link only supports Microsoft SQL smoothly. Remaining all are a little bit hard, but this entity framework will support any database structure you are using. Okay, code will never change, only the database can change. The code can still remain the same. All right, it can map table from one to many, many to many. Any relationships can be done using this ORM framework. Okay, now this is the theory part, guys. Okay, so please note the entity data model. Please remember the keyword here. There are a lot of full forms and abbreviations here. The abbreviations, what I want you to remember here are EDM, Entity Data Model. Okay, it is a schema language which consists of three things: conceptual model, mapping model, storage model. Okay, so you can see these three things are available. So I'll explain all those things, but just remember the keyword alone. Entity data model, that consists of three other things: conceptual model, the mapping itself, and then finally storage model. Okay, there are three things there. Okay, so let's go to the diagram. This is the architecture of entity framework. Okay, this is what I want you to know about the theory part here. Okay, so let me start with the last one here. What is the final target here for us? The final target is a database. It can be Microsoft SQL, it can be Oracle, it can be any other database. So you have a database at the left hand side. So first one, what you will have, your request. Okay, through HTTP, request comes here, and here in between what happens? Okay, that we will see from here. Either way, even if you are using ADO.NET, please note here, what is available here is basically an ADO.NET right next to what do you call the SQL, Oracle, other. On the right hand side, you see the green databases just organized there. Okay, it directly talks to ADO.NET only first. Okay, that's why I said it's built on top of ADO.NET. All right, so basically what is ADO.NET? Connected, disconnected way of retrieving, inserting, updating, deleting records. So that is there in the bottom. That is not written by us, it's written by the system. Earlier we used to write it. In entity framework, system is going to write it. So what will be above that? Entity client. Okay, which is what we are going to write code, which is basically called as entity data model, which is there below for you. You can see entity data model. And in entity data model, there are three: conceptual, mapping, and storage. All those three are, three are there. Okay, and then before that you have object services, which is because you have to convert all your database structure to an object oriented class object structure. Okay, so that is where this part comes into. Select 0 O from orders, from O in entities. Like for example, this side you see that link to entities. From, it starts with from. Okay, that is link to entity. So you write all these things here which talks to objects, and that object services will talk to the entity client, which will have this structure which helps you convert whatever you've written in object model to a SQL model, and then gives you the result. Okay, so this is the architecture of entity framework, guys. Please do note this. This is important for theory purposes. But in real world, all you need to do is to understand that you are going to write a language integrated query to entities, which means you're going to query an object. Okay, and that object is going to be mapped to a relational database table. That's all I wanted to remember. Again, I'm going to repeat that formula. One instance of a class in programming language. In object-oriented programming, an instance of a class is equal to one row in a table. Okay, an instance of a class is equal to one row in a table. Please remember this formula. Do not forget that. That's the basic mantra of an object relational mapping. Okay, please remember this. And I'm not going to take much, but then let's say standard features of entity framework is to map tables, views, stored procedure, function as .NET objects. Please note the keywords what I've used. It maps tables, views, stored procedure, function. All these four belong to databases. Okay, what is the work of entity framework here? Entity framework just makes sure that all these things, tables, views, stored procedure, function, is converted into a .NET object. Okay, please remember that object is object-oriented programming structure. All right. So second one, it provides link-based data queries. That's why I said, even though we are going to learn entity framework now, query will be looking exactly like language integrated query, which we did in the previous class. So it's not going to be something new for us. It's going to be same. Only thing is the code will be little bit different, not totally different. Okay, please remember that. Moving on, it performs CRUD operations, obviously. Okay, and then you have compiled queries. You also have trigger or stored procedures. You can use all these compiled queries for that particular purpose. And also you can create or delete this database schema itself from the entity framework feature. Okay. So what is the life cycle here? Entity framework translates into SQL. Please note, even though in ADO.NET we write SQL directly. So there is no translation there. SQL is going to get executed. That's all. But when it comes to some middleman in the middle for us, like ORM, we need to translate that whatever I wrote in object-oriented way into SQL. So the language integrated queries in the object model. Please note, entity framework translates into SQL the language integrated queries in the object model. We write link query in object model, which gets translated into SQL using entity framework. Okay, and then entity framework sends them to the database for later execution. Then it gets executed in the database itself. Okay, so when the database returns the result, okay, what will the database return? For example, if I say select star from table name and I execute this query, your table will return a number of rows. Okay, please remember, when I say select star from table name in a particular table, the table normally returns a number, n number of rows, all right, which are not understood by programming. So what programming entity framework should do, should convert all those rows into .NET objects. Okay, into objects. Let me just use another word, into instances. Okay, so just think that if I have one row in a table, it should be equal to one instance of a class. What is an instance of a class? In other words, we can call that as an object. Okay, so please remember, if I retrieve like 10 rows from the table, from the database table, what am I getting back? I'm getting back 10 objects, 10 .NET objects. I hope you follow, right? So the database server is transparent and hidden behind the API. We are not touching the database server directly, but rather we are using entity framework to do that for us. Okay. It is executed over iQueryable as an interface. At compile time, a query expression tree is emitted. At runtime, SQL is generated and executed. This is the life cycle of entity framework. Okay. And let me not get into this components. I've already spoken about context in the previous class. If you remember, what we created as that database, like a database, what we created was, I think I used employee. So you remember employee LTS data context. Okay, so the context is nothing but the one which holds the database connection and the entity classes. Okay, it's like that the picture which you saw when you dragged and dropped a table, you got a class diagram, and that entire file, what you see with n number of tables, that is called as the context of your database. In other words, it holds the database connection as well as the entity classes. So which means I need not bother about the connection string, I need not bother about opening the connection, etc., etc. Okay, and it provides link-based data access. It implements identity tracking, change tracking, API for CRUD operations. Everything is there. I'll show you that. Okay, and each database table is typically mapped to a single entity class. Okay, please note how it works. A database, okay, actually doesn't store data. It stores tables. Tables store data. So you have database, table, data. This is in database or relational databases. What about in programming? In programming, you have in C# specifically, you have namespaces. What is a namespace? It is just a package which holds other classes. Okay, so namespace, then you have class, and inside the class you have objects. Okay, so please remember, database, table, data. On this side, you have namespace, class, object. Okay, you can map them. So basically, each database table is mapped to a single entity class. In other words, C# class. Table is mapped to a class. What about the rows in the table? Will be mapped to the objects of that particular class. Okay, that's all. There are associations allowed and concurrency control, which means what do you call, the avoiding of deadlock and stuff. Okay, all those things are taken care by entity framework itself. No need to bother about it. Okay, in databases we used to write code for that, or we need to find a way to avoid that, but here it is inbuilt. Okay, now the last one is, you need to remember, in the last class what I used was a link to SQL class. A link to SQL class. File extension was .dbml. .dbml was the file extension in link. Okay, link to SQL classes. But when it comes to link to entity files, in other words, entity framework based files, the file extension is EDMX. Okay, entity data model. Please remember that, EDMX. All right, entity data model XML. So mappings are normally stored in .edmx files. Okay, and normally it's an XML file, but then it also has its own designer.cs file. Below that you can see that whatever database name you give, .edmx is an XML file. It holds the metadata representing your database schema with conceptual mapping or storage. Okay, when it comes to last one, designer.cs, it contains C# classes and the object context class. One entity class for each mapped database table. Okay, this is how EDMX would be there. I'm not going to show EDMX. Let me show it in the code itself. Okay, so I'll skip this. Look at this. The name normally will have entities attached to it. All right, so for example, a database name is Northwind entities, and then you create an object. This will be the instance of your context. In other words, the file which holds everything. Okay, I'll normally name this object as DB. It acts like the database. It's the context of your table. Where all your tables are stored is the database. Where all my classes are going to be stored. Okay, all those mapped classes are going to be stored. It's called the context in which I'm getting stored. Okay, so the context in which it is stored is the database. In relational databases, the context in which my tables are stored is the database. In object-oriented programming, the context in which my data is stored is object context class. Okay, that name will be given to you by the system itself. I'll show you that shortly. Okay, so remember this. And in the constructor, you can pass a database connection string or mapping source, etc. But not required. System will automatically take care of all these things. Okay, so look at that code, guys. I think I need not explain that. Just look at the first block. Okay, var customers is equal to from C in context dot customers. Okay, what is context here? It acts like the database here. So I put DB. So if I say DB dot table name, so from C is the range variable in context dot customers, where C dot city. Now whatever is available in customers will be available in C. I hope you guys follow, right? That's what we've been learning in language integrated query. This will be a temporary placeholder for all the data which is coming from the data source. So context is database, customers is my table name. So whatever you get from the table name, store it in C. And then I'm saying where C dot city. Okay, there is a restriction here. In that object, what you get, if there is an object which has the name as city and it has London in it, then select that, which means select all customers who belong to the city of London. I hope you guys follow this. Okay, the query is not new to you. This is entity framework, but it is not looking like entity framework because it looks like language integrated query. Okay, that's why I said if you learn link to SQL, this is not going to be difficult at all. Okay, but one thing is this is purely object oriented. Okay, it will not automatically map anything. You will have to convert into an object model. Okay, for example, in language integrated query, if you remember the data source, I set the grid view of data source. Like for example, I said from row in db.table name, select row. And then I said whatever is returned is the data source. I cannot do that in entity framework. That is allowed in link to SQL because link to SQL returns a collection of data, but here it returns an object model. We will have to convert it into a list if you want to use it as a pure object oriented programming. I'll show that in working, but there is small differences. But which is better, link or entity framework? Obviously choose entity framework. Okay. And the query will be executed as SQL command in the database. That's how it works. If you wanted to see, in some case, some people want to see what query is getting executed, you can just do like this. You can call that query as object query and then print it. It will print the native SQL query which will get printed, but is not required. I'm just telling this as an information. Okay, so how do you create a new class? Okay, so same just like how we had done. Don't get confused with this syntax, guys. I'll use this syntax. I'll introduce you to this syntax in this class. Okay, but please remember, if you wanted to insert a row in the table, if you want to insert a row in a table, what am I supposed to do according to the formula? According to the formula of ORM, a row in the table, okay, is equal to one instance of a class. So all you need to do is create an object. Okay, so you can see there, you are creating an object of order. Order space, order name you want to keep, okay, object name is equal to new order. And then I'm saying order date is equal to some date, okay, and then shipped date is equal to something, shipped city is equal to something, like that we are keeping. Okay, and then finally I'm calling the database, context is nothing but database for us, dot orders, which is my table name, dot add object, then pass this object. That's all. Once you pass this object, an instance of a class, if you add, basically what you're trying to do is you're inserting a row in the table. And finally, you'll have to save changes. In link to SQL, we use the word submit changes. Here we are using the word save changes. That's all. Okay, there are small differences here and there, but please remember this. Okay, that save changes method is used to required to post the SQL command to the database. Okay, this basically will actually execute an insert, SQL insert. Okay, how do I update? Same like how I did it in link. Only thing is, final line you have to say db dot save changes. There I said submit changes. Okay, that's all. All right, so that's it. Last one, deleting, same way. How we did it in link, same way we have to delete it, but then save changes. Do not forget that. Okay, so let's go to the project. So let me just start. Let me share my screen with Visual Studio on. Okay, I hope you guys can see the screen. Now I'm creating a new project. Okay, so I'm going to name it as Entity Framework Demo, and I'm going to create a new project with web forms. Remove configure and then click on create. Okay, so what I'm going to do right now is basically create a simple project. Okay, let's choose let's say some product table we'll take. Okay, so what we are going to do is I'm going to create a table quickly. I'm not going to explain much because I think these first steps are all very much clear to you guys. So all I'm going to do is create a database and then create an entity framework model which will do all work for me, like how I did for link to SQL classes. But just not like link to SQL. Here, entity framework should be part of your Visual Studio. When you have installed typical community edition of Visual Studio, should have entity framework. Okay, because it is not something which is like an add-on. But link to SQL was given as an add-on for some people because it is not used much because it only supports Microsoft SQL. But what we are going to do today, I'm going to use Microsoft SQL only. But still, please note that I can use any database which I feel like. Okay, not just Microsoft SQL. The reason why I'm using all Microsoft SQL in all my programs is because that's the only thing which works properly in the lab. All right, so if it is your laptop, please feel free to try any database you like. Okay, if you find any difficulty, let me know. I'll help you how to figure that out. Okay, MySQL requires a plugin, guys. Please remember, Oracle I think has inbuilt support. Microsoft SQL has inbuilt support, but for MySQL, you will have to install a plugin from their website, MySQL's website with .NET. Okay, they'll give you a separate provider. And then once you add them, then you can start using MySQL in your Visual Studio. Okay, so please remember that. So let me just quickly start with the project. I'm going to create a table. So let me go to Solution Explorer. Let me right click and add a new SQL Server database. Okay, so I'm going to name this database as product DB. I'm going to add it to app_data and let me go to Server Explorer once it is added and create a simple table called TBL products. So let me go to Server Explorer and let's pick up one data connection, productdb.mdf. Okay, so from here I'm going to create a new table since there's no table in the beginning. Let me right click on the tables folder and create a new table. Okay, and do not forget this, guys. I'm repeating it a lot of times because people have made this mistake in the past. Never leave the word table as it is. It will be named as table itself. At the bottom here, you will see SQL query getting generated. Never forget to change that name. Okay, name will be by default given as table. Do not leave it like that. Change it into something which is meaningful for us. All right, so let me just name it here as TBL products. Okay, I'm naming it like this because it's my convention. It doesn't matter. You can change it however you want, how you want to name your table. But then let it be a meaningful one. Don't put TBL1, TBL2, etc. Make sure that the table is, the name itself is self-explanatory. Okay, this is a table which holds product details. You can also put product details or just products. I'm just putting as products for our understanding. Okay, I'm going to put that as prod_id. Let it be auto increment. Okay, so let me just change the property to identity specification true. Let it start with one only. So one is done. Next one is prod_name. Okay, so I'll just put it as varchar. Do not forget to change it. It should be varchar. All right, and next one is quantity. I'll put quantity is equal to is an integer as well as price. Okay, price right now I'll keep it as integer. In the next programs I'll be making it into double. Okay, so nothing can be null. Everything should have some value. Default quantity will be 0. You can put that also here, and the price will be 0. Okay, so that's default if you want to keep it. If in case you're not giving, by default 0 will be inserted, something like that. Okay, so my table name is right now database object table TBL products. Okay, so please note it is TBL products. Let me click on update and let me update the database once it is ready. And I'm going to add only one record. Remaining everything I'm going to take it from my program. Okay, so let me click on update database. So once it is done, let me go back and refresh and see whether that table is there, what I just created. If it is there, let me just open it. Sorry, show table data. And here I'm going to add one data. So I'm going to say pen, quantity 50, price is 5. Okay, done. So one record I've inserted. Let it be there. So let me just go out and let's go to the program. So I have my table design. Table is ready. What's my next step? Okay, so once your table design is ready, the next step is to make sure that the table what you have created is now mapped to object oriented way. For that I need entity data model. Okay, so please remember the title, what I said, ADO.NET Entity Model. Okay, so let me just add, right click on that particular project and click on add. Let me choose a new item. Okay, I hope you guys are noticing this. Okay, next one is data. I'm going to look for data and choose the first one which you see there, ADO.NET Entity Data Model. Please remember the word I said, EDM, Entity Data Model. In the slide I discussed about that. Okay, ADO.NET's Entity Data Model. So I'm going to name this as Product EDM, so that you know it's entity data model. That EDM, there you remember I put it as LTS, so that you know it's linked to SQL. Here I'm putting EDM so that you realize this is the entity data model. So it's product EDM. I'm going to click on add. Okay. I'm adding. So first one, there's a wizard coming in front. It's asking me a few questions. Number one, how do you want to create this model? The content of this object model, entity data model, where will it come from? Okay. So there are four choices given to me. One, entity framework designer from database. Second one, empty entity framework designer model, which means the first one and second one, what is the difference here? The first one, it creates a designer from database which you already have. Okay, second one is creating empty data entity framework, empty designer model. Then you are adding the data what is required. Both are fine. Okay, I prefer the first one to avoid two steps. The other one is two-step model. This is one-step model. Okay, what about the remaining two which is there? Okay, please note when it is a mapping. What is the mapping between? The mapping is between entity. Sorry, the mapping is between an object-oriented programming language and a database model. Okay, a relational database. So I have two entities in the middle. So normally what we do is we create the database, then we write SQL query in order to manipulate, or through C# or Java we write SQL query to manipulate that database. This is one way of writing. Okay, there is another way of writing with code first. Okay, what do you mean by that? Okay, first what we do is we don't create database. What I did right now, I'll omit that. I'll go to code and I'll write code which will in turn generate a database. Okay, that's also possible. Since I'm not going to focus on that, I'm going to take this one because we are familiar with that. I'm going to choose the first one, entity framework designer from database. Let me click on next. When you choose that, since you already have an MDF file in your project, system automatically chooses which data connection should your application use to connect to the database. Please note, I already have productdb.mdf already in my project, so it's already retrieved that and kept it here. But what if I don't want to use MDF and I want to use a new connection? You can click on new connection. You can choose any other data source. Please note, only support directly given for is Microsoft SQL and SQL Server database file. Anything else, you will have to write code. Okay, you'll have to write extra work. You have to tell what is the connection string, etc, etc. Okay, so I'm going to ignore that, but just note that you can change the database also. It need not be Microsoft SQL. It can be any other database, relational database also. Okay, so a connection string is being generated, and you can see that what I said, CSDL, SSDL, etc. Everything is getting generated here, and it says save this connection settings in web.config as product DB entities. Please note the name what comes there, product DB entities. All right, this is the context of your tables. Okay, what is the context of my tables in database? In relational database management system, the context of my table is my database. In object-oriented programming, the context of my classes is this entities, this file, product DB entity. This is the context. Okay, so let me go to next. Let me say okay with all these things. Please don't remove this checkbox. Let it be added to the connections settings. Okay, let me click on next. Okay, which entity framework do you want to use? This is because I have both. It is showing. If you have only one, this dialog will be ignored. Always choose the recent version. It's better. Okay, so let me just click on next. Okay, now while the database retrieval information is going on, I want you to notice this at the bottom. There are some more things. Let me zoom for a minute. Okay, I hope you guys can see that. Okay, so one, it says pluralize or singularize. Okay, generated object name. What do you mean by pluralize or singularize? If I had given product, you will get products. Okay, if you have given products, this will make it into product. I hope you got it. Pluralize, singularize object name, so that you know the difference. Why do I do this? Because my if you think your database is a collection, you name it as products because it's a collection of data, right? But when it comes to object-oriented programming, you take product class singular. But if you want, you can take vice versa also. That's why it's pluralize or singularize. All right, and the namespace of this will be product DB model. All right, so let me just ignore that. Let me go here and see which table database objects do you want to include in your model. Let me open the database object here and see my table is there. Okay, in tables, I have DBO, my database object. Which one is there? The one which I just created, TBL products, that is there. So let me just choose that and click on finish. That's it. Okay. You guys can revise the steps what I did once again in this video. Okay, but let me just continue. So my work here is done, and once I've finished that, I should be able to see exactly like how we had seen the other day with respect to link to SQL classes. Okay, we need to see a designer, okay, which has the class diagram ready. So we need a designer. Let me see whether it comes. Okay, now before I proceed, please note this: everybody will get this dialog, security warning. Okay, you'll get this dialog. Do not forget what I'm saying here. Okay, always choose do not show this message again and then click on OK. Let me focus on that warning again. Running this text template can potentially harm your computer. Do not run it if you obtained it from an untrusted source. Okay, we are the source here, so don't worry about it. Choose do not show this message again and click on OK to run the template. So once we are done, the output what I'm expecting is something which will look like a class diagram. Okay, just like how we saw in link to SQL classes. Okay, I would like to see that diagram now. So here now you see the class diagram is ready. Now we have a table structure here. Okay, so with this in mind, let's move on. I have the table design. I can just make sure that this is saved. Okay, so there's a star there, which means it's not saved yet. Let me just save it so that it's finalized. Okay, so this is like a class diagram what we saw on the other day. With this, my work of the mapping of object-oriented programming and the database here is done. My next step is to directly go to write code. Okay, so I need not bother about connection string, etc., because in the first step itself, everything else is taken care of. All right, so with that in mind, let me proceed. Let me go to create a new file. So let me just add a new item. Okay, so let me just add a simple web form with the master page. Let me name it as a display. Okay, so it will be retrieve.aspex in other words. Okay, so I have a simple file. Let me just take that. And inside that, I'm going to put only one thing, the design grid view. Okay, I guess you know what I'm going to write the same, because I'm following the same pattern in all my programs, so that you at least get the concept. I'm not focused on the CRUD operation here, rather how that CRUD operation is happening in different technologies, so that I'm using the same structure for all my projects. You can modify it however you want, guys, but I'm showing the same structure so that there's no confusion. All right, so once the page is ready, let me just drag and drop a grid view. So let me put a grid view, and let's go to properties. Okay, let's name it as GV, and let's put let's say this is products. So I'm going to say GV products. Okay, so grid view which holds products. I guess by now you know how to modify the column name, so I'm not doing it. Okay, so with that in mind, let me just go to the CSS part. I'll just change that part and then I'll go to the code. Okay, so CSS class, I'm going to put table hyphen bordered, or however you want. You can keep that. All right, so that is done. Let me go to the code. So let's tap F7. Let me come to the page display. All right, so here, how do I write the code? Okay, please note, I need you to make sure that you understand the properties of this context. Let me click on properties outside. You will find the name of the entity container. Okay, I hope you guys can see that here. Entity container name is product DB entities. This is the name which I want you to focus on. Okay, you need not bother about anything else. So let me just go back to code and let me write the code like this. Using, okay, let me write using product DB entities. Let me name it as DB is equal to new product DB entities. So whatever I write inside this using block will be having the object access to it. The moment I come out of the using block, DB will be automatically closed. Okay, this is a C# structure. So please do remember that. Now, since I have the database, I can directly go to the query. So I'm going to say var, let me say result is equal to, I can write normal, what do you call, link query from, okay, so let me just say data in db dot, I'm looking for TBL products. That's my table name. Select data because I don't have any restriction. I just want everything. In other words, select star from table name. Okay, please note this is wrong in entity framework. It is okay in link language integrated query to link to SQL. It is correct, but here it is not correct. Okay, I'll tell you why shortly. But let me just finish it. GV products dot data source is equal to result 1. GV products dot data bind. Done. Okay, I hope you guys follow this. All right, so this is done. But now this will not work. The reason is because the data what you have returned, okay, will be a collection. Please note what is the data which has been returned in the range variable is an object of TBL product. Please note not products, TBL product, singular. All right, so I would like to convert this entire thing into a proper C# construct so that it can be displayed or put in the grid view. Okay, so let me run the program. Let me see what is the error, then we'll come and fix it. Okay, but please note this is not going to work because it's not like exactly linked to SQL. The code looks similar, but it is not going to be like that. Okay, so now there's an error. Okay, so let's see what the error says and we'll find out what is it is. Okay, let's see whether it's possible for us to read this. Okay, so just look at that. Data binding directly to a store query. DB set, DB query, DBL SQL query, DB raw SQL query is not supported. Okay, please note that it is just saying that it is not supported, but it also gives you a solution. For ASP.NET Web Forms, you can bind to the result of calling toList on the query. Please note, it also gives you an answer of how to fix this error. Okay, data binding is not supported because it is entity framework. Okay, so for ASP.NET, you need to make sure that you call toList on the result. Okay, please remember this. So let me just do that and see what happens on the result. What is the result here? Result is already here. So let me just call dot toList. So what happens here? I'm converting that whatever data comes here into a proper C# construct called list. And then let me run the program once again. So the output is got. So now our work is done. This is entity framework retrieval. Let me quickly do the remaining part also. Let me just add a new record. So let me just add a new page. Okay, so let me add a web form with master page called insert. Okay, so let's see how to create a new product. Okay, so with that, let me go to design. Let me put a table and quickly put the controls. So I'll use a HTML table and let me put a few controls starting with, I think product name is required, and then I need the price and the quantity. So quantity, and then we want price. So 3 things I'm asking. The other product ID is automatically generated, so I don't require that part. Okay, and I need a button, so let me just put a button also there. Okay, so that is design part. Now I'll just write enter product name. Okay, I'll say quantity and price per unit. Okay, done. So my work here is done. Let me just choose these 3 controls and go to CSS class. I'll put form hyphen control for these so that they become like bootstrap controls. The last one is that button. So for that, I'll put btn hyphen success. Right. So now let me just go and change the properties one by one. First one is txt product name. Second one is txt qty I'll put. The last one I'll put txt price. The final one is the button. I'm going to put btn insert, or you can put btn add or whatever you want. I'll just put add product. Done. So my design here is done. Let me just go to the code part. Okay. So in the code part, all I need to do is to get the data that I can take it directly from the code because you have come to this particular block. So let me write the same code what I wrote there using product DB entities. DB is equal to new product DB entities. Okay. So inside that, now all I need to do is to create an object. Okay. Please note I'm going to use the previous structure what I used in link here first. Then I'll show you a different structure. Okay. Let's start. You need to give an object of TBL. So just put TBL, you will get product. Please note not products. My table actually is TBL products, plural. It has singularized it here, TBL product, because I'm going to create one object here. Okay, so I'm going to put it as product is equal to new TBL product. Okay, this is one way of writing, guys. I'll write two ways so that you know. Okay, once I created an instance of a class. So I've created an instance of this TBL product class. All I need to do is call product and then you can set the values. I need not set the product ID, but I can set the product name. Please note prod underscore name was given in my database. I'm going to get that from txt name, product name dot text. Simple. Next one, product dot prod underscore or let's say quantity, I guess. Quantity is equal to whatever you get from the text box, parse it. So I'm going to say txt qty dot text. Okay, next one, product dot what's the next one? Prod underscore price is equal to, again same, int dot parse txt price dot text. So I've got all these things. Okay, but please note all I've done so far is just create an object with some data there. Okay, this is an object model. I need to add this object model or convert this into a database. So how do I do that? All I need to do is call the database object, which is nothing but my context here, dot your table name, TBL products, dot add. Okay, add what? Add an object of TBL product. So we are just going to add the product called TBL products dot add this object called product. That's all. And then finally save changes. Done. Okay. This is somewhat similar to what we had done in link with respect to adding. Okay, but only difference is instead of add, we have put it as add object and I gave the object name, and instead of save changes, I gave submit changes. Okay, so please remember that. That's all is the difference here. Now, as I was already telling you, there is another way of writing this code. Let me just show you how to write another way. Okay, let me just comment this for a minute. Let me show you how to create that. I can also put TBL product space product is equal to new TBL product. Okay, please note I can write like this. Without closing that, I can still continue writing price. Okay, you can keep writing like this. Price is equal to what it is. Okay, you can write it in one line also. Instead of that, I can write it like this. Okay, so please note I've just created a TBL product. So when you now press control space, only those four data will be asked. What I did right now is I did not close the TBL product like this. Instead of that, I put a flower bracket and press enter. It will come like this. Okay, you can put semicolon and stop it there. But in between, what you can do is I can write the same thing there. Prod underscore name is equal to. Okay, I can just copy all these things. Txt pname dot text. I'll put that. No need to put semicolon. You can put comma because it's continuing. Okay, next one is let's say quantity. Quantity is equal to this one. Okay, and comma. Last one is price. Price is equal to whatever is here. This is also right. Okay, this is one type of writing this. This is another way of writing this. Whichever is easier, whichever is clearer to you, take that model. Not a problem. Okay, this is another way of writing it in C#. Okay, so that's it. This is all. If you click submit now, it will get added. Okay, so I hope you have got the logic. With this, can you try the update part on your own, guys? If you could try that on your own, it will be great. In other words, I mean, if you are not able to do that, next class I will do that. So I'll stop with this for today's class. Please try the update and delete on your own, guys.